Hey guys, welcome to Algebra 2, lesson 1A.5, solving quadratics using the quadratic formula. Solve using the quadratic formula. Well, when do we do this? Well, first of all, the quadratic formula can be used anytime on any quadratic. It always works. It's the one tool that'll work on any single quadratic. Factoring is a shortcut really, and so is completing the square. When you can use those other two techniques, I recommend using them because they are a little bit more efficient. But the nice thing about the quadratic formula, like I said, is it always works. So first thing we want to review, what is a standard quadratic? So it looks like this. We're going to be talking about A, B, and C today. A, B, and C are simply the coefficients. A is the coefficient of the x squared term, B is the coefficient of the x term, and C is the constant at the end of the standard form. The quadratic formula is x equals negative b plus or minus square root b squared minus 4ac all over 2a. Now you are given this formula on your Regents formula sheet, so you might think you don't have to memorize it, but as a pre-calculus teacher, I should say, I'm telling you, you do have to memorize it. There are certain formulas in mathematics that we should know. This is one of them. So I am going to require that you have this memorized. Let's take a look at how to use it. Example 5, x squared minus 4x minus 6 equals 0. The first thing you might try to do is factor that, but I think it's pretty obvious to see that there are no factors of 6 that will subtract to 4. Now this one would be a great candidate for completing the square, right? Because that coefficient is 1 and that's even. And if I had a choice, that's the method I would use. But since we're practicing the quadratic formula today, that's what we're going to do. So as I'm doing this, be aware of this formula and where we're getting the numbers. Maybe for the first example, it's a good idea to write out those coefficients. So in this case, A is 1 because that's the coefficient in front of the x squared. B is negative 4, and C would be negative 6. Now we want to be efficient, but we also don't want to rush. We can think of this, we say negative b, but really what that is the opposite of b. It doesn't mean it's negative, it just means we change the value of b to its opposite. So when I start out this quadratic formula, I'll say x equals, because we're finding roots, it's x equals, the opposite of b. So if b is negative 4, the opposite of that is 4. So I'll write down 4. Plus or minus square root. Now, I like to do this without a calculator, and the reason is sometimes we forget to put the b term in parentheses before we square it, and that negative out in front leads us to all sorts of problems. So I am going to recommend, as long as b is a single digit or a relatively small double-digit number, you do that in your head. We should know those perfect squares anyway. So if b is negative 4 squared is 16. So I'll put 16 in here. Minus 4 times a, which is 1, times c, which is negative 6, all over, and again, I think we can double pretty much any number, so 2a, if a is 1, is just 2. What I'd like to see next is that you put what we call the discriminant, which we'll get into later, but that's this part, not the square root, just what's underneath. Put all of this into your calculator to get that radical. So I get 4 plus or minus square root. And if I put 16 minus 4 times 1 times negative 6, and that would be over 2. Now we need to simplify. Square root 40. We can break that up to square root 4, square root 10. All of this is still over 2. And the square root of 4 is simply 2. So now what I have is this expression, x equals 4 plus or minus 2 radical 10 all over 2. Here's where we have to be careful. The way we simplify, there's a couple methods you can do. If you want to keep this as a single fraction, one big fraction, you can cancel this as long as you cancel it with both terms up above. So you might have heard this referred to as like a special triangle. But what I would prefer to see is that you break this up into two fractions, 4 over 2 plus or minus 2 radical 10 over 2. Then you can simplify each one. So 4 over 2 is 2, plus or minus 2 radical 10 over 2 is just square root 10. So here are your two roots. One of them is 2 plus square root 10, one of them is 2 minus square root 10. Okay, number 6. Notice that's not in standard form, right? Our standard form is equal to 0. So I need to subtract 10 from both sides. So let's do that. It gives me 2x squared minus 3x minus 10 equals 0. Again, this maybe isn't necessary for each one, but as we're getting used to using this quadratic formula, a is 2, b is negative 3, c is negative 10. So let's just plug into that formula. X equals the opposite of b, so that's going to be positive 3, plus or minus square root. B squared, negative 3 squared is 9, minus 4 times a, which is 2, times c, which is negative 10. Don't forget that, that's very important. All over 2 times a, which is 4. X equals 3 plus or minus square root. I'll get that in a second, all over 4. What I'm going to do in the calculator is put in 9 minus 4 times 2 times negative 10 and get that value. That gives me 89. I actually like this. The reason I like this is because you cannot simplify square root 89. There's no perfect square that goes into 89. So if you can't simplify that radical, we are done. There are your 2 roots. Okay, last 2. Number 7 looks a little bit weird. And I'll be honest with you, I probably wouldn't use quadratic formula on this particular quadratic, but I want to show you that it works no matter what we have in terms of A, B, and C. The reason this is a little bit weird is because we're missing a term. So A is 1, B is 0, right? If you don't see a Y, that's 0, and then C is negative 5. Now, the quadratic formula says x equals, all right? And I'm guilty of doing this all the time. I get in a habit, I'm like, oh, x equals. But notice your variable here is not an x, it's a y. So technically, we should go y equals. The opposite of b, well, it's just 0, plus or minus square root. B squared, that's just 0, minus 4 times a times c all over 2a. Now, 0 plus or minus anything is just going to be plus or minus whatever this stuff is, and then I have to divide that by 2. So this kind of goes away. What that leaves me with is plus or minus square root. I would put this stuff into my calculator, which is pretty easy. We could do it in our head, right? It's negative 4 times negative 5 is positive 20 over 2. Now we can simplify square root 20. So let's see, plus or minus, that would be a 4 and a 5, and the square root of 4 is just 2. So y equals plus or minus 2 radical 5 over 2, and then the last thing we do is cancel those 2's, so it's just plus or minus square root of 5. All right, last one. Notice here it says round to the nearest hundredth. A good indication we need to use our calculator, and a good indication we're either going to use completing the square or the quadratic formula. So once again, this is not equal to 0 though, so I need to subtract that term over. So that gives me 3d squared plus 3d minus 7 equals 0. And again, they kind of make it a pain because they change the variable on us, so it's not x equals, it's d equals to find those roots. D equals. All right, the opposite of b, so in this case it's negative 3, plus or minus square root. B squared, which is 9, minus 4 times a, which is 3, times c, which is negative 7, all over 2a, which is 6. Now I'm going to take an extra step here because I want to know what is underneath the radical. So I will take a second to put this into the calculator. 9 minus 4 times 3 times negative 7, and I throw that into the calculator, that gives me 93. Now, if this just said solve or simplest radical form, we're done. But because it specifically tells us to round our answers to the nearest hundredth, I need to put this into the calculator. And remember, there are 2 roots here. One root is going to be negative 3 plus square root 93 all over 6. The other root is going to be negative 3 minus square root 93 all over 6. This is really pretty easy from here on out because we just put it in our calculator. Please take the time to create a fraction in your calculator so you put this whole expression in there exactly the way you see it. Don't do this and then just hit the divided by key and put in a 6 because it does not do this properly. We're dividing this whole thing by 6. So create a fraction for that. If you do that correctly, negative 3 plus square root 93 over 6 is 1.11 to the nearest hundredth. And negative 3 minus square root 93 all over 6 is negative 2.11. All right, and that's it. That's the last day of notes for Unit 1A. Today's lesson was solving quadratics using the quadratic formula. Thanks for watching, guys, and as usual, if you have any questions, please do not hesitate to come in and get some help. Bye.